Welcome to Bednik Tutors YouTube channel. In this channel, we will be breaking down topics of each science subject in order for you to have a better understanding of each topics. Because as a teacher, we believe that every student should understand fully every topics they are being taught. So, in order not to miss out on any of our videos, because all the videos we'll be uploading are very important, please do well to subscribe to our YouTube channel. Also, like and share. We also have a Telegram channel where you can communicate with us, ask us questions, and meet with other educators. The link of our Telegram channel is in our YouTube bio and comment section. Now, say these after me. I understand mathematics. I understand physics. I understand chemistry. I understand further math. That is a spirit. Bednik Tutors. Excellence is our word.
How are you? So we'll be looking at a missile is launched still on the dimension analysis. We're looking at a missile launched vertically upward with an initial velocity u at an angle theta to the horizontal. Full stop. Which traveled a horizontal distance r, often referred to as the range, which is represented by the expression r is equal to u squared sine 2 theta over g. So if r is equal to u squared sine 2 theta over g, determine the dimension of r. So we want to look for the dimension of the range here. Is equal to u squared over g. So we are not going to consider the sine 2 theta since it is dimensionless. Angle is dimensionless. So we're looking at this. So we have to identify the quantity of this and the quantity of this. So u is initial velocity. So publicly, the unit is m square over s square. So the dimension will now be L, because meter is L, seconds is T, so that will be L square over T square. So we should make this like that. So then we can now move to the G, which is gravity or acceleration due to gravity, which is meter per second square. As far as the unit is concerned, for the unit is meter per second square. So for the dimension of G, that will be meter is L, while this is T square. So that is done. So since R is equal to U square over G, so we can now say our R will now be L square over T square divided by L over T square. So that is that. I'm sure that's clear. So if that is done, we can now say R is equal to L square over T square multiplied by T square over L. So this will cancel one of this, because here means L times L. So this cancel one of this cancel this. So my range is now L. So that's all about that. You can see from the beginning that our range is u square over g. So unit is meter square. Our unit is in meter square. G meter square. For the velocity is meter per second. There for the unit there is meter per seconds. But when you now square it, it becomes meter square over L square. So the dimension of of initial velocity. Summation of the velocity. Initial velocity is L square over T square. So then for the acceleration, G is acceleration due to gravity. B, the unit is meter per second square. So the dimension of G will now be meter is L. So here is T. That will be T square. So the range will now be U square over G. This is the dimension for the initial velocity L square over T square divided by L over T square. So at the end, L, one of these L will cancel this. T square will cancel T square. Remain only L. So that's the range. So I believe that works perfectly well. So very simple to analyze. Very simple to analyze. So it's as simple as that. In terms of surface tension. Yeah. So surface in terms of our solution. So surface tension is equal to force over length. Surface tension is force over length. If you open force up, force is mass times acceleration. Then over length here. So when we look at the unit, so mass is kg, acceleration is m over r square, then a is m. So from here we can now say this over 1 kg times m, kg m over r square will now be divided by m. So we want to solve it easily using some unit and convert back to dimension. So here this over 1, here will be kg m over r square applied by 1 over m. So this will cancel this. So at the end we have kg over r square. Under dimension, kg is m, y seconds is t square. So this can be written as m over t square like this, or mt minus 2. That means the denominator now, the denominator dimension, for it to become the numerator dimension, the positive power here must have negative. If it is negative, when you bring it to the numerator, it becomes positive. So that's just all. We need to know from one quantity, how one quantity can lead to another. Surface tension is just force over length. And you know force is mass times acceleration. The acceleration is velocity over time. So we just click on the unit of the acceleration. From there we converted the unit to dimension. You can likewise say from here, just say ml over t square divided by l. So simply ml over t square divided by l, and still we solve it along that line too. So very simple. Thank you. The force F acting on the wings of an aircraft moving through air of velocity v and density is given by the equation F is k v is equal to k v raised by s density y a raised by z, where k is dimensionless constant and a is the surface area of the wings of the aircraft. Use the dimensional analysis to determine the value of x, y and z. So it's y 20. So we look at F from our work. F. So looking at F is equal to k v raised by x times v raised by x times density y times a raised to power z. So let me put the z. So from here we pick each of the quantity. We are going to pick each of the quantity. Here will now be my f. F, which is my force, is equal to mass times acceleration. So which is under units. For the units, I have it as kg times m over l square. So I'll just convert to the dimension directly. I'll put it as my kilogram. Have my kg is denoted with m, then my meter is denoted with l, then t square. So over 1. So my f under dimension will now be ml over t raised to power 2. Okay, that's settled. That's for the force. So that's that. That's the conversion. Force is mass and acceleration. My mass is kg, my acceleration is meter per second square. So this is m over 1 times l over t square. F is ml over t square. So that's settled. I now move to what we call my velocity v, which is my velocity. So the unit of velocity is v, is meter per second. So since here we don't be l over t under the dimension, then raised to power s. Okay, this can also be written as lt. With this raised to power 1, if I bring it up, become negative. So negative index of indices. So that's that. Then my density means density. Symbol for density. So if density is mass over volume, so the unit of mass is kg, volume is meter cube. So under dimension I have m, meter cube is l raised to power 3. So that means my density is m over l raised to power 3. Then I put raised to power y. Okay, that's that for equation 1, equation 2. So I'm sure that those illustrations are clear to us. It's from one of the quantity. We open the force up, we open the velocity up, we open the density up, we want to open the area now. So I'm going to clean the upper part. I want to open the area by that. So from here, I will now say my area is equal to meter square, which should be l square, and raised to power z. So from here, I can now, from my illustration, f, which is equal to k v raised to power x, density raised to power y, raised to power z. So for the dimension analysis, I can now say my f, which is m l square times l square, then my t raised to power 2, I will bring it up. That will be t raised to power minus 2 is equal to, then my velocity will now be l, here is raised to power 1. So I will do x times 1 here. X times 1 here. That will be l raised to power 1 times s, t raised to power minus 1 times x. That's for velocity. Then multiply by, the next one is density. I'll look at density here. This will be m raised to power 1 times y times l raised to power minus 3. Here can be written as m l raised to power minus 3, then raised to power y. So that will be l raised to power 1 times y. This m raised to power 1 times y, then l raised to power minus 3 times y, multiply by, then after that is done, I move to the area. The area will be l raised to power 2 times z. So we want to do a comparison of the force with the three quantity here. Comparison of the force with the three quantity based on the dimension of all of them. So that we can get x, y, z. So from here, I can now say, from here, this m raised to power 1. So I can now say that m raised to power 1 is equal to m raised to power y, because 1 times y will be y. So 1 is equal to y. So I will say here t, my t there is minus 1. So we write that. So here will be t raised by minus 2 is equal to t raised by minus x. So minus 2 is equal to minus x. So divide this side by minus 1. So here will be 2 is equal to x. So 9 is equal to 2. That is the first answer. This is the second answer. And now move back. My L raised by 2 will now be L raised by x times L raised by minus 3y times L raised by 2z. So here is L raised by 2 is equal to L raised by x plus minus 3y plus 2z through multiplication law. 2 is equal to x plus minus 3 over y plus 2z. So from here now, I have my 2, which is equal to plus times minus minus, that's x minus 3y plus 2z. So my 2 is equal to, here will now be, if you recall, you have to recall here, x is equal to 2, y is equal to 1. So here will be 2 is equal to x, 2 minus 3 open bracket 1 plus 2z. So 2 is equal to, here, since y is 1, so here will be minus 1 plus 2z. So let's look at our L from here. Mass times acceleration. Okay, let's confirm. Acceleration. So, my L is 1 there. This was a mistake. L is 1 there. So it can be L is power 1. Please correct this. This L is power 1. Yeah, because that is ml over t. So because we discovered that the mass is ml raised by 1 over t. Since it's kg, yeah, it's L raised by 1. Please take note of that. This is L raised by 1. So here will now be, here is 1. Please correct that in your work. This is 1. This is also 1. So it's L raised by 1. This is T1. Please take note of that. There is L raised by 1. This subsequently, the lower part, I think I've erased that, but know that force is m raised by 1 times L raised by 1 times T raised by minus 2. So here will now be 1 plus 1 is equal to 2z. So 2 is equal to 2z, we will say by 2. 1 is equal to z. So we can now say here, therefore x is equal to 2 according to what we calculated here. Y is equal to 1 and z is equal to 1. So those are the correct answer there. So the question is concerned. So it's as simple as that. Because we are just comparing the force with the velocity, with the density, and with the surface area. Q is equal to half PV square, where P is the density and V is the velocity. We are told to find the dimension of Q. So from here we realize that if we have Q as half PV square, so P is density. So if P is density, we know that P will now be mass over volume. And in terms of unit, it will be kg per meter cube. So under the dimension, we have our P will now be m over L raised by 3, or ml minus 2 because the denominator dimension, when you turn it to numerator, the power of that denominator is 0. So if that is done, we can now say from here, volume V, which is volume, no, velocity rather, V, which is velocity will now be, and that will now be meter per second, which is L over T. So since we have it as V square, that will now be L over T square. So that will be L square T square. So from here, our cube, half does not have any dimension. So here will now be L times L raised to power minus 2 times from, let's say, pick from PV square. So Q will now be L times L raised to power minus 2 then times L square times T raised to power minus 2. So Q is equal to M raised to power 1 L raised to power minus 3 plus Q times the apply multiplication law T raised to power minus 2. So Q is equal to M raised to power 1 L raised to power minus 1 then times T raised to power minus 2. So our definition of Q will now be M L minus 1 T minus 2. So because minus 3 plus 2 will give us minus 1. So we said, what physical quantity does Q represent? We want to look at the physical quantity of Q. So if we want to observe the physical quantity of Q, let's look at quantities like prayer. Let's check prayer. So when it comes to prayer, let's confirm prayer first. Or let's confirm prayer because this is okay, because M means mass, L means length, or length, you can say distance, so T means time. We want to look at some quantity that make use of this. T is distance, T is time. So we want to look at quantity that make use of this. So because force is mass times acceleration, which is ml, so it can be force. Let's look at prayer. Prayer is force over area, which is mass times acceleration over area. That's what we know the quantity this could represent. That would be m times L over T square. And if we check prayer Q, we discover that if we are validating P is equal to force over area, so this is mass times acceleration divided by area. This is m times L over T square divided by 1 over L square. So from here, this will cancel this. So it is only one half. So we have m times 1 over T square times 1 over L. So automatically, we've confirmed that prayer is n L minus 1 T minus 2. So we can now say Q means prayer. Q means prayer or Young modulus. Both of them are the same. Young modulus. Prayer or Young modulus. So the effective potential energy of a lunar satellite of mass m moving in an elliptical orbit. So we talk about a lunar satellite, it moves in an elliptical orbit of a moon. It is given by B is equal to, that's the effective potential energy, K square over 2m1 R square is equal to Gm1 M2 over R square. So when R is the distance of the satellite from the moon and G is the universal gravitational constant of the dimension. So here's the formula for that. The dimension there, then that was m is per minus 1, m is per 3, 2 is per minus 2. We are told to determine the dimension of the angular momentum K of the satellite using the dimension analysis. So here is a frame of a moon, the moon will be spherical. You see the satellite revolving around it. So it's due to the interaction between the moon and the satellite, they both now bet what we call an effective potential energy. So there's an effective potential energy based on their relationship. And you know the satellite will be revolving around the surface of the moon, revolving around the surface of the moon. I think that will also be discussed under the topic linear momentum. So let's look at E is equal to K square over 2m1 R square is equal to Gm1 M2 over half. So we want to find the dimension of K. So what we need to do is that this electric potential energy is equal to this. So we want to make K subject of formula. So we are equating these two formulas. Okay? We are equating these two formulas there. That is the formula of the satellite and that of the moon. Because of how they relate together and they form what we call the effective potential energy. So we need to solve that. That's why equating is very simple. You see the illustration for that one. Yeah, we are going to look at, so if E solution, if E using the formula there, we have K square over 2m1 R square is equal to Gm1 M2 over half. So we cross multiply. That will be K times R square is equal to Gm1 M2 times 2m1 R square. So divide both sides. So yeah, K square half. So K square half. Now divide both sides by half. So you can now say from here K square will now be 2G M1 square M2 is M1 square M2 then multiplied by R square divided by half. So R here will cancel all of this. So at the end we have K square is equal to, can we use it? Because this has cancelled this. To only single away. Then we started with, let me start again. K square over 2m1 R square is equal to Gm1 M2 over half. So if that is solved, we can now say from here K square over 2m1 R square is equal to Gm1 M2 over half. So we cross multiply. So after cross multiplying this, we now say K square times half. Then Gm1 M2 times 2m1 R square. So at the end, we now multiply the variable side by R so that K stand alone. So we are finding this angular momentum K. This will now be 2G M1 square R square M2 R square then over half. This will cancel one of this. And then we now have 2G M1 2G M1 square M2 R. So from here, we have to find first from 2 is dimensionless, numbers are dimensionless. You take note of that, numbers are dimensionless. Yeah, take note of that. So we can also do, we can also from here, K square is equal to, yeah, G is M raised power minus 1 times M raised power 2 times T raised power minus 2. Then multiply by the M minus 2, that's M raised to power 2. So we started with K square is 2 mg is m raised power minus 1 times m raised power 3 T raised power minus 2. The gravitational constant of the moon has been given to us already from the question. Then the M1, those are the three masses there. That's one made to the m raised power 2. Then I have is so here will now be K square is equal to m raised power minus 1 multiplied by m raised power 3 then times l raised power 3 times L times T raised power minus 2. So my K square is just m raised to power 3 multiplied by here will be, we have m raised to power 3. That will be m raised to power 3 times maybe is not times m raised to power 4. We added that maybe is 3 raised to power minus 2. So here we are going to multiply this power of 2 by half. So that here will also be multiplied by half. So this will be 3 power 2 times half is equal to m raised power 2 times m raised power 4 times t raised power minus 2 multiplied by half. So this cancel this, we have k is equal to m raised power 2 times half multiplied by m raised power 4 times half multiplied by t raised power minus 2 times half. So if you use the power of half to apply these two product law of indices, apply this, you also multiply this. Are we together? So those are ways of resolving that. So we can now continue from that. Lesson 2 1 2 lesson 4 2 here quantity is minus 4. So from here we can say our k is equal to m raised power 1 times l raised power 2 and times t raised power minus 1 because the 2 here has cancelled this to become 1, the 2 here has cancelled this to become 2, here has cancelled it to become minus 1. So I can now say k is equal to, we always put inside brackets, and l raised power 2 t raised power minus 1. So that's our answer.